Let's learn how to read DNA fingerprints. Fluffy is my white-haired cat. She sometimes likes to have her meals on the back porch, so I put her dish of cat food outside. Recently, she's been whining and complaining because she's hungry. After doing a little detective work, I realized that another white-haired cat has been eating Fluffy's food. However, there are other white-haired cats in my neighborhood, and I can't tell which is eating Fluffy's food. You're going to help me figure out which is the criminal. This is suspect number 1, suspect number 2, Fluffy, and the crime scene. Of course, Fluffy will be found at the crime scene because it was her bowl. So see how every line with Fluffy lines up with one line from the crime scene. So, who else lines up with the crime scene? Is it suspect 1? Nope. Is it suspect 2? Yes. Yes. Yes and yes. So suspect 2 is the one that ate her cat food. For 3 years, a team of researchers have been watching 3 different humpback whale pods off the coast of Hawaii. They are especially interested in the genetic diversity of these whales. As the number of humpback whales are decreasing, determining the genetic diversity of these populations is increasingly more important. In particular, this team is interested in identifying the parents of one of the new baby whales, Luna. Through their observations of nursing behavior, they have matched Luna with her mother. However, none of their observations has helped them link Luna to her father. Today you are going to help them figure this out. So this is Luna's DNA, this is the mother's, and here are the 2 whales we think are the father, candidate 1 and candidate 2. Now, remember, a baby gets half its DNA from its mother and half its DNA from its father. So, for example, Luna got this line from her mom. She got this line, well, her mom, her dad, and both candidates, they all seem to have it, so that one doesn't help. And she got this line from her mom. So see how the mom passed on half her lines? The dad should have passed on about half as well. Now we already said this one doesn't help. So, that looks like it matches with this one. This looks like it matches with, well, either one. It's kind of hard to tell, isn't it? But this can only match this one. So this has to be the father. These are real DNA taken from actual court cases. This was a sexual assault case. This latter is just a bunch of different DNA pieces of different lengths, so it helps you compare the rest and make sure the DNA is running correctly. So you may ignore all of the latter lines. This is the control. This is just testing it to make sure it works right. And this line should end up right here, this one should end up right here, and if it didn't, you know something went wrong. Then we have the victim. Her DNA has this line and this line. Then we have suspect number 1. He has these lines. Suspect number 2, he has this line. Here are the female cells found in the evidence. So there are her cells proving that she was at the crime scene, because obviously she had to have been there. And here is the sperm DNA. Who does this match? Oh wait, we also have the boyfriend's DNA, just in case. So, who does the sperm DNA match? The boyfriend, suspect 2, or suspect 1? Please circle the correct answer. This time we have a paternity test. So here is the mother, the child, the alleged father, a mix of the child and the alleged father's DNA, and of course the latter to make sure everything is running correctly. The mother provides half the DNA to the child, the father provides the other half. Does this match with the father's? Does this match with the father's? Then they mix the child into the father to show that this dot and this dot are actually two separate dots. They're not on the same line. What about this one? In this case, the mother passed on this line to the baby, but not this one. Then, did the father pass on this line to the child or not? And here is the child and the father, so you can see that's all the same line, and it did not separate out into two different lines. So, is this the father or is this the father? Circle the correct dad. And finally, we have some babies that were switched at birth. So this is the mom's DNA and this is the dad's. Sorry, they got a little bit off. Then this is the baby's DNA, baby 1, 2, and 3. So let's look at baby number 1. The first line for baby number 1 matches with this line, which is from the mom. All right, let's keep going. This line from the baby also matches up with this same mom. This line from the baby matches up with the dad, who's from the same couple. This is looking good. This line lines up with the mom. This line with the dad. This line with the dad. And that's it. So we know that couple B goes with baby number 1. You keep going and figure out which baby belongs to couple A and couple C. Then finish answering the rest of the questions. Let's do some of these together. Explain why not all the bands in the mother's or father's profiles have a counterpart in the baby's DNA. Notice, all of the lines from the baby matched up to either the mom or the dad. But not all the lines of the mom matched up to the baby, and not all the lines of the dad matched up to the baby. That's because the mom only passes on half of her genes, and dad only passes on half of his genes. The baby gets half of its genes from the mom and half from the dad. I think you can get number 5 and 6. Number 7, identify the largest DNA fragment on the gel. Remember, these are little wells or holes into which the DNA is poured. Then electricity is run through, and the electricity causes the DNA to move and spread out. Which DNA piece is going to move the furthest, the lightest or the heaviest? Well, if you think about it, it's easy to move the light piece and it's hard to move the heavy piece. So this is the lightest, shortest piece of DNA, and this is the heaviest, longest piece of DNA from this mom. Okay, so what is the largest DNA on the whole gel? It has to be this one. So circle and label largest piece of DNA. How do you know it's the largest? It moved the least distance. Then you will be able to identify the smallest piece of DNA, and I'll bet you know how it's the smallest. And answer how you knew it was the smallest.